Welcome to Gozroth Tutorials. I'm Gozroth, and today we're going to take a look at tap to move. And in this tutorial, we're going to create a top-down tap to move and a third-person tap to move. And just to showcase what we're going to create, here we have our top-down, so we can move wherever we want. So we can either tap and it'll move into that position, or we can move and drag and it'll always follow. And then for third-person, we have our third-person camera. And we can click and move, or we can click and drag to wherever we want to go. And then the camera will follow and stay behind the player. So here we are in a brand new world. And there's a couple things that we're going to need to get this to work. First, we're going to need a raycast. Go to Build, Gizmos. I'm just going to find our raycast, and we can just drag this in. It doesn't matter where you position it. I always like it at 0, 0, 0. We need to make sure it collides with objects, and we're going to set the tag to floor. We're going to leave the raycast distance at 2000, and then we're going to make sure it stops on the first hit. Next, we need to create our floor. So we're going to go to Build, Shapes. We're going to grab a cube, bring that in, rename this to floor, and then we're going to put the position to 0, 0, 0, and then we're going to scale it on the X and the Z. That way we got a nice floor. We do need to create a gameplay tag. We're going to call this one floor. There's one more object we need to create, and that's an empty game object. So we're going to right click in our hierarchy, create empty game object, and we can name this tap to move. I'm going to zero this position out as well, and then we're going to attach a new script. We're going to call it tap to move. And since we're going to be adjusting the player's camera, it does have to be a local script. Go to Scripts, and then the three dots here, go down to Execution Mode, make it local. Okay, so now let's edit our script. Let's do some beginner cleanup. I don't like importing everything, so we're going to remove that, and we're going to add component and get rid of the HZs. Then I'm going to format my document. That way my spacings are correct. Now before we get started, there's a couple other things I want to add. We will need to import the local camera, and that's going to be from Horizon Camera. Make sure we end our line. In the props definition, we're going to want a reference for our raycast gizmo. So we're going to call it raycast gizmo. And it's going to be of type entity, so we're going to go type, and it's going to be prop types dot entity, and we're going to need a private variable for our owner. So we're going to go private active player of type player or undefined, and then we have to import our player. And then in the start function, what we want to do is we want to set this dot active player to this dot entity dot owner dot get, and then if this dot active player does not equal this dot world dot get server player, we want to do something else. We'll do something else. If the active player is not the server player, what we want to do is we want to put them in focus interaction mode. So we'll go this dot active player dot enter focus interaction mode, and we're also going to disable the exit button. So we'll go disable focus exit button, and then we'll set that to true. The next thing we want to do is connect to one of the focus interaction mode methods. So it's going to be this dot connect local broadcast event. It's going to be player controls, and we have to make sure it's imported. It is, and it's going to be on focused interaction input moved, and it does give us some data. So we're just going to go with data, and then we're going to do an arrow function, and it's going to be this move player to position. And we don't need all the data, so what we're going to do is we're going to go data dot interaction info, and then we end our line. We have an error because the move player to position method does not exist. So we're going to go to copy that, go down to line 21, and we're going to create it. And it's going to be interaction info. And if we hover over interaction info, we can see it's of type interaction info array. Interaction info, and make it an array. And then we can do something. So here we'll move player to position. Next, we want to adjust the player's local camera. So what we're going to do is we'll go local camera dot set camera mode attached. We're going to attach it to the active player. So it'll be this dot active player, and we want to give it some offsets. So we're going to create that. So it's going to be position offset, and we want it to be above the player. So we're going to give it a new vector 3. It's going to be 0 on the X, 10 on the Y, and 0 on the Z. We also want it to look down, so we're going to give it a rotation offset. It's going to be of vector 3, so new vector 3. And then we want it to rotate down, so we're going to go 90 on the X, 0 on the Y, 0 on the Z. And then we can close out our line. If we don't add a timeout here, it can cause an issue, so we're going to go this .async .set timeout, and we're going to end that. And then underneath that, we're going to give it a timeout of 100 milliseconds. And since it's now inside of this timeout, we're not checking this, but since we're checking it here, we can just add the exclamation mark. This is one of the rare instances where you can do the exclamation mark. Now, before we can test this, what we need to do is transfer ownership. Ideally, I would use an asset pool gizmo, which we will eventually, but in order to test this, we're going to use onPlayer enter world. So we're going to create a pre-start method, pre-start, and in the pre-start, we're going to connect to the CodeBlock event. So this dot connect CodeBlock event. It's going to be on this dot entity code block events with an S. It didn't import, so we'll import that quick. Now we can access all of them, and it's going to be on player enter world. This does pass a player variable, so if we hover over this, we can see on the top line here, player of type player. So what we're going to do is rounded bracket, and it'll be player type player, and then we're going to do an arrow function, and we're just going to call this dot on player enter world. We'll just copy that, and we'll make sure we pass in that player variable. Then we can end our line. Again, we have an error because we didn't create the method yet, so we'll just do that quick. On player enter world, player, and then in here, all we're going to do is this dot entity dot owner dot set player. We hit the save button, and when we go back to the editor, and when we hit the play button, we get our 90-degree top-down view. But before we add anything to move player position, I want to create an event subscription. So we're just going to call this, we're going to copy the name on focus interaction input moved. We're going to go down on line 9, hit enter a couple times, and create a private on focus interaction input moved event. And we're going to make that of type event subscription. Make sure it imported, it did, and I may want to make sure it's either that or undefined. And then what we're going to do is we're going to copy that, and then on line 22, we will this dot on focus interaction input event equals our connect local broadcast event. We can cache that event as a subscription. If the owner is now the server player, in our else, we're going to check if this dot on focus interaction input moved event. So if that has been set, we will do two things. We will go this dot on focus interaction event dot disconnect. So that way it disconnects that event, and then we're going to this dot on focus interaction input event, and we're going to set that back to undefined. So that's just a little cleanup. That should prevent any memory leaks with the event system. Now we can move down to move player to position. We want to make sure that the active player has been set. So we'll go if not this dot active player, we're going to return. We're also going to make sure that the array that we're receiving has a length greater than 0. So if interaction info dot length equals 0, we're going to return, and then we're going to cache the very first index of interaction info. So we'll go const first interaction equals interaction info first index. And we want to make sure that the first interaction's interaction index doesn't equal 0. So if first interaction dot interaction index does not equal 0. And if it doesn't, we want to return. We only want that first interaction. Here is where we check for our raycast gizmo. So if not this dot props dot raycast gizmo, so if it hasn't been set, we want to return. But we also want to inform the developer, so console dot warn, and what we're going to add is that raycast gizmo is missing or null. So if they forget to set it, you'll get a yellow warning in your console saying it's missing, informing you to set it. And then we'll return. So we don't want anything more to run. Next, we are going to fire the raycast. So we want to get that hit. So we're going to go const hit equals this dot props dot raycast gizmo, and we have to then cast it as a raycast gizmo. And we want to make sure that it imported. It did not, so we're going to go up here and paste that in there. And then we have access to its methods, so we can go .raycast. And raycast asks for an origin and a direction. And there's some options that you can add if you want. The origin is going to be first interaction dot world ray origin, and then we also get a first interaction dot world array direction, and then that's all we need for that, so we can close out our line. So now we can get a hit. Next, we want to make sure that that hit actually hit something, so we're going to go if not hit, we will return. And then finally, we're going to go this dot active player dot move to position, and we're going to use the hit dot hit position or hit point. And there's a couple options that you can use. So we're going to go in here, and we have acceleration, deceleration, face movement direction, movement speed, and travel time. So we're just going to adjust the move speed, and we're going to set it to whatever we can set it to whatever we want. The default move speed is 4.5. Go back into the editor. When I hit play, since I have already played it and we showed the 90-degree angle, when you play it again, you're always going to get this because of how the player exits the world. Like ownership doesn't transfer, and then some things don't fire, and I'm not entirely sure what the bug is, but the way to fix this, so if you end up with this, all we have to do is shut down the server. Now that we are back, we can hit the play button, and we can now move around the world by tapping. So eventually you get to that point, it'll stop, or you can just click and drag since we're using the moved event. So we're going to go back, and so we have a lot of places where we're just hard coding numbers, and I don't like doing that. So what we're going to do is we're going to create some props definitions to hold those numbers. We have a props definition for our top down camera distance. It's going to be of type props number, and our default will be 10 is good. Oh, I forgot a comma up here. And then we're going to create another one that's going to be top down camera pitch. It's also going to be a type prop number, and our default will be 90 because we want it to be 90 degrees. Move speed, also going to be of type props number, and we'll leave it at 4.5 for now. So now we can replace these hard-coded variables here. So 10 will be this dot props dot top down camera distance. We'll use our pitch in here where we have our 90. This dot props dot camera top down pitch. And then our move speed will go down here. We'll reset it. So it'll be this dot props dot move speed. And what this does, when we click on our tap to move object here, we can now adjust these variables without having to go into the script. The next thing we want to do is add a third person view. Right, so let's go back into the script. We want both top down and we want third person. I'm going to create a Boolean props definition. We're going to call this is top down. It's going to be of type Boolean, and we're going to set the default to true. Go into start. When we have our timeout, we will check. So if this dot props dot is top down, we will set our local camera to the mode attached with the player. But if it's not, we're going to set the local camera dot set camera mode attached, but instead of the player, we're going to use this dot entity. Now the reason we have to use this dot entity instead of the player is because if we were to use set camera mode follow, it won't rotate behind the player using the move to position method. So we have to move the camera ourselves. And the best way to move an object manually is through on updates. So we're going to then connect to the on pre-physics update event. So this is going to be this dot connect local broadcast event. It's going to be world dot on pre-physics update. We're going to get the data from that, which is just delta time, and we're going to call an arrow function. It's going to be this dot update, and we're going to pass data dot delta time. And again, we haven't created updates, so we're going to create that quick. And the only thing that we're going to receive is delta time of type number. But we don't want the update running all the time while we're in third person. So we're going to add a couple checks. So first it's if not this dot active player, we're going to return. And we're also going to make sure that the player is actually navigating. So we're going to go if not this dot active player dot is navigating. So this only is true while the player is moving using the move to position. So if it's not doing that, we don't need to worry about updating the camera position. If we use this dot player dot forward, it uses the forward of the player's head. So unfortunately, we have to get the forward manually. So we do have to do some math. So I apologize if this is a little complicated, but this is the only way to make it look good. So first we need to get the player's position and the player's root rotation. So we're going to go const player position equals this dot active player dot position dot get. And then we're going to go const dot player rotation equals this dot active player dot root rotation. So we need to have a reference to the x, the y, the z, and the w of the quaternion that is the root rotation. We go const x equals player rotation dot x, const y equals player dot rotation y, const z equals player rotation z, and then const w equals player rotation w. So now we want to manually compute the forward vector using the root rotation. We're going to create a variable that we can change. So we got to use let player forward. It's going to be of type vector 3, so vector 3, and we're going to set it to vector 3 dot 0. Now we have to set the individual vector 3, so x, y, and z manually. So we're going to say player forward dot x equals 2 times w times y plus x times z. Player forward dot y equals 2 times in brackets here, we're going to go y times z minus w times x. We can close out that line. And then player forward dot z equals 1 minus 2 times x times x plus y times y. I put an 8 instead of a asterisk there. And that is how we're going to get the x, y, and z. And now we need to go player forward equals player forward dot normalize, so we can normalize that vector. So now that we have the forward of our player's root rotation, now we can figure out how far back we need the camera, using that to get the position that we want. So in order to figure this out, we got to go const behind horizontal. We're going to set that to a new vector 3, and the x is going to be minus player forward dot x, and we're going to multiply that by how far back we want to go. So let's just say 5 for now. We're not adjusting the y, and then we need to do the same thing with the z. So it'd be minus player forward dot z times 5. Now we need to figure out what the desired position is. So we're going to go const camera position equals player position, and we're going to then add our behind horizontal, and then we're also going to add a new vector for our y. So then we can do something like 0, 1, so it's a little bit higher, 0. So now that we have our position for where we want the camera, now we need to set the camera. So now we can just go this dot entity dot position dot set, and we can set it to the camera position. It's always going to be behind the player, but if the player were to rotate, like move in one direction, the camera is not going to rotate with it. So we also want to update its look rotation. So what we're going to do is we're going to create another variable called const look direction. It's going to be player position dot add. It's going to be a new vector 3, and we're going to use 0. How high we want it, so we can just use 1 for now, 0, and then we're going to subtract the camera's current position. That way we get a direction. So b dot sub this dot entity dot position dot get. So we're setting look direction to the player's position plus a offset for the y, and then we're going to subtract the camera's position. That way we can get a direction. And now we want to then also get a target rotation. So we're going to go const target rotation. We're going to set that to a quaternion because rotations are quaternions. And it didn't auto import, so we're going to roll up here and we're going to import quaternion. So we have access to those methods, and the one method we want is look rotation. And then look rotation requires a forward and an up, and our forward is going to be our look direction, and our up is going to be vector 3 up. So now we have a target rotation, and we're going to then set this dot entity dot rotation dot set, and we're going to set it to our target rotation. So now we're going to click on tap to move. We're going to make sure everything is set. We still have it set to is top down, so we're going to turn that off. And now when we play, we should have our camera behind, which it is, and I should be able to move the player. Now the camera is a little jittery because we're not smoothing out that rotation, which we'll do here in a step, but we can see that we do have a third person camera, and it is following the player and it is looking at the player, so that is working. In our update function, right before we set the position, so first we're going to go const current position, so we get a reference to our current position, and that's going to be this dot entity dot get, and then we're going to set a time variable, so const t, and we're going to clamp it so that it doesn't get crazy. So we're going to use clamp, and then in our clamp we're going to set the value to delta time and our lerp speed, how fast we want it to lerp. So we're going to multiply that by 5. And then we're going to set a min of 0 and then a max of 1. And it looks like it didn't import clamp, or it doesn't like clamp. So we're going to import that quick, fix that error. And we need to update the individual positions of the current position to get our new position. So we're going to go const new position x equals the current position dot x. But we're also going to add our camera position dot x minus the current position dot x, and then we're going to multiply that by t. So then we're going to do that for our new POSY. We're going to equal that to the current position dot y plus camera position dot y, and we're going to subtract that from the current position. We're going to multiply that by t as well, and we're going to do the same thing for z. And then once we have that, we can then get our smooth position, which is going to be const, so we're going to call it smooth position, and that's just going to be a new vector 3 of position x, position y, position z. And then instead of passing camera position, we're going to pass our smooth position. So now that we're smoothing out our movement, we also want to smooth out the rotation. So instead of setting rotation to target rotation, we're going to use quaternion.slurp to smooth that rotation. So we're going to go in here, we're going to type quaternion.slurp. Make sure we have our brackets. We're going to use this dot entity dot rotation.get. We're going to pass in our target rotation, delta time times our slurp speed, so we can use 5 again here. And when I hit play, now it should be really smooth. There's more jittering, it moves good, and it rotates good. So now there is some cleanup that we want to do, and the first thing is I want to create some variables like we did for the top down. So we have our variable for our lerp speed, so we can go lerp speed, and that's going to be defaulted to 5. And then we'll have a slurp speed, which will also default to 5. And we can replace down here where we're using that. So here's our lerp speed, so be this dot props dot lerp speed, and then we can go down to our rotation here and replace this 5 with our slurp speed. And now we're going to do our third person camera variables. So we'll go third person camera height, which is going to be a number. We'll default that to 2 for now, and then we'll have our third person camera look height, and that we can default to, I think we used 1, but 1.5 is fine. And then we'll have another one, third person, and this will be the camera distance, and yeah, let's default that to 5. So let's take our third person camera height. So this is dealing with the position, so we'll go down into our updates and where we set our position here. So camera position, we're just going to replace this one with this dot props dot camera. Oh, I spelled person wrong, so we're just third person, and we'll update our variable up here. And then our look height in our look direction, we'll just replace this one here with this dot props dot third person camera look height. So then we have our third person camera distance, which also deals with the positioning. So in our behind horizontal, where we have our 5, we can go this dot props dot third person camera distance. So now all these variables can be adjusted in the properties panel. Now we want to do some more event cleanup. So we're going to create another event subscription. However, this time we're going to do it for on pre-physics updates. So So we're just going to replace that and make it on pre-physics update event. All right, so then we're going to copy that, and then when we connect, we're going to just go this dot on pre-physics update event equals, and we're going to make it equal to this broadcast event. And then just like before where we checked, we're also going to make another check, but this time it's going to be the on pre-physics update event. And we're going to disconnect and reset that back to undefined. However, we're going to create a method to handle this. We're just going to call it cleanup. And this way, if you ever need to call it outside of start, we have that. So we're just going to move it down into our cleanup. And then if else, we'll just go this dot cleanup. And then I'm going to create one more props definition for our timeout here. That way it's easier to set. So we'll just call this camera switch delay. And that'll be of type number. And since it's in milliseconds, we'll add ms to the end of that. And then we'll just default it to 100. And then we'll copy that. Where we have this with this dot props dot camera switch delay. So let's click on tap to move, and we can adjust. So let's leave it as a third person, and we can adjust the camera height. So like how high the camera is going to be behind the player, and we can adjust the look. So before we had it set to 1, and now if we hit play with it being at 1.5. It's a little bit higher, so now it's at its waist instead of at its knees. So you can adjust those values to get the camera exactly where you want. Now in the beginning of the video, I said that we were going to use the asset pool gizmo, so let's add that quick. We're going to go to build, gizmos, asset pool, gizmo. We're going to bring that out, and then we can just call this the tap to move pool. We're going to zero out the position because it doesn't really matter where it's at. We're going to auto assign to players. We're going to auto pool size, and then we need a reference to the asset. So before we do that, I do want to go into player settings and just bring that down to 1 for testing. We need to create this as an asset. So we're going to right click on our tap to move object, create asset, and I'm just going to go tap to move tutorial. Create. I can delete that. I will grab a reference to our tap to move tutorial. So now it'll create one for each player. I have it set to 1, so there should only be 1 in here. Okay. Now we got to go back in the script because I forgot to get rid of our pre-start and our on player enter world. So we can get rid of our co-block events. Now that we made a change to the script, we have to click on our asset, and we do see at the top here that there is an override. So we're going to review that, and we're going to hit apply. So that should update the asset in here with the new version. And when I hit play, it does update the camera and works as intended. And one other thing I wanted to show you, it's not really related to it, but it does look pretty good in portrait mode. So if we were to change our camera to portrait, it does look pretty good. You might have to adjust the camera a little bit, but it does still work really good in portrait mode. And that is all I have for tap to move. I will be creating this as a public asset, so that way you can pull it in and it should just work. So if you have any questions, comments, or concerns about the video, or any suggestions for a future video, please let me know in the comment section below. Also, if you liked the video, if you learned something, don't forget to like, subscribe, and hit that notification bell so you're notified of all my future videos. And yeah, thanks for watching and have a good one.